Thank you very much for joining us in this live. Now, today we will be talking about longitudes and latitudes that we ought to have done yesterday, but due to some unavoidable circumstances, we could not make. So, thank you for coming back. Now, thank you very much for joining. I'm Teacher John, a maths teacher, maths and physics actually, and I'm working
with the Kenya Science Academy and online, in which I'm coming live right now. Now, if you have a struggling child, committed but struggling child, we are offering structured lessons from all the curriculums, be it CBC, be it Kcse, be it IGCSE, GCSE, American system, Australian system. We are offering GCSE of UK, and we are offering IB system. So today, I want to take this humble time to at least let us share something small with the Form 4s of this year, that is latitudes and longitudes. So with me, I have a calculator, so ensure also you have your own calculator. I have some examples. I have a set in case of anything. Have also your exercise book, and let us start. So let me share my screen so that you see whatever I'm doing. Just a minute. Now, that is my screen. And as you can see on the board, I have latitudes and longitudes that I'm sharing right now. So let us start asking ourselves, where did this latitude and longitude thing come from? The first time I get latitude and longitudes, that is class 7, that is social studies, when you are learning longitude and time. Then the second place I got latitudes and longitudes also in Form 1 in geography. Those people who did geography in Form 1, you can understand latitudes and longitudes were also part of our Form 1 geography. Then next we can, those people also who did, not those people who did, of course, all of us, we did maths, Form 4, and this is now the third time we are getting latitudes and longitudes. So here is a story, and this story, one thing we need to understand is that initially, before us, some people were surviving, and at a point, I used to ask myself, who came up with this thing called mathematics? Because it is broad: algebra, calculus, we have trigonometry, we have geometry, and so on and so forth. So it was a point 10 years ago, I was asking myself, who discovered mathematics and what was he thinking? So specifically, longitudes and latitudes. I've been asking myself, who is this that came up with this latitude and longitude thing? And what was he up to? So I came and realized that latitudes and longitudes started with the Greeks. We have Greeks astronomers, and astronomers are those people who are studying the sky, heavenly bodies, and other things. So Greeks were the first people who started going around the Earth's surface looking for things that did not exist. So where could I learn this? Yeah? And what was I thinking? How can I think in order to come up with this latitude and longitudes? So back then, Greeks were very active in wisdom, and they were trying to come up with different things that would make human beings and their lives more comfortable. So right now, we have the aeroplanes flying. You just sit in your plane and you are taken where you're being taken. And at the end, you land without knowing the direction where you're going. But the pilot knows. That's an amazing thing. Then the next thing, imagine also the sailors. If you find yourself in a sea or traveling by sea, the captain knows wherever you are going, and they are using their calculations, and they know even the distance they are going to cover. To make the matters worse, they know the distance and the speed and the altitude where they should be. That's also a very interesting. Now, how did they knew this? Of course, they went through training. They were trained on what to do and where and when to start the motion, and also where to go. So, number one thing we need to understand that these longitudes and latitude things. So, longitude and latitude, longitudes and latitudes started with the Greeks, and the Greeks astronomers plus geographers. So as we did geography as a subject, and because we were told that geography, one of the things that we were told that geography, it is a career subject. Now, those people back then, they never went to school to study geography, but already they were geographers. So back then, people were not going to school, but they could get interest in the earth and study it. They could get interest in what is beyond the earth. That's now the astronomy, the stars and heavenly bodies. That's now what astronomers were doing. So Greeks astronomers and geographers are the ones who started these longitudes and latitudes, though it is not one person's invention or it is not one person's work. A number of people came together. So what do we need to learn today? We want to do whatever they did back then and help ourselves solve the problem. So right now, you and I, we can assume that we are pilots. So we are pilots now. We are learning latitude and longitude in order to fly plane full of 200 passengers on board. So fly with me. Let us obstacles we are going to meet, and it is you and I who are going to work these obstacles out in order to come up with a meaningful life and ensure that the passengers arrive safely. My question is, are you ready? Yes. So since I'm ready, and I know you are also ready, and for those people that will be joining, please, I want you to understand that we are looking at latitudes and longitudes today. So let us start our lesson. Now, what did they start with first? So they started by comparing the latitudes, the Earth as a whole, and other objects like spheres that look like the Earth. So they were assuming that the Earth is spherical and it is in a ball-like shape. So I think you can imagine how a ball is looking like. Of course, it is made of infinite number of circles. So it is a ball-like shape. So they were comparing that sphere and looking at the Earth in the form of a sphere and coming up with the deductions and conclusions that they come up with. So imagine that. So in short, they were trying to come up with a similarity and enlargement. So anything that looked like Earth to represent the Earth. So let us start with what they came to realize. So we have first, they were talking about great circles and small circles. So great circles great circles and small circles. Great circles and small circles. So we have a circle and a small a circle. Let me underline my work. So when dealing with great circles and small circles, what was their point of interest? They wanted to know, are there some lines on the Earth's surface that will be looking at looking like the lines that they will be drawing in future, or using these spheres? So great and a small circle. What did they do? What did they do? So let us consider under a great and a small circle. Let us consider. So we have a diagram. We can name it part a diagram of a sphere. So that's now a sphere. Take it as a sphere. Then part B, we also have a sphere. So part B, we also have a sphere here. So here in part A, we have 3 circles drawn. So they drew 3 circles whose planes are perpendicular to the sphere's axis. So this is a sphere. So we talk of the sphere's axis. So we have circles whose planes are perpendicular to the sphere's axis. So these circles, let us name them A. Then we have a circle B. Then we have a circle C. Then here, instead of drawing circles running from east to west in a sphere, they did something very different. So this my diagram is not that perfect. So let me draw another one. So we have a circle. Perfect. This one is at least. So here we have the north pole of the sphere and the south pole of the sphere. Then the next thing, what did they do? They drew other circles from the north pole to the south pole, then to the other side. So this dotted line is showing how that circle is working. Then this side, then we have another circle drawn. Then we have another circle drawn. So take these ones as circles. So let us discuss 2 parts. We have the first part A. We have figure A and figure B. And figure A, we have 2 circles drawn on the sphere. We have circle A, circle B, and circle C. In figure B, we have also different number of circles drawn, but the difference between circles in A and circles in B is that circles in B are coming from, or they are meeting at one point, at 2 points on the sphere, the North Pole and the South Pole. In A, those circles are not meeting at any point, but they are drawn whose spheres, we are being told that the planes are perpendicular to the sphere's axis. So a sphere is taken to be having an axis passing through it. And if we rotate the sphere, it rotates about its axis. So these are the 2 examples of spheres that Greek geographers and philosophers were using in order to do what? To come up with the latitudes and longitudes, and also to calculate the distances on the Earth's surface, and also the speed with which a body can move around the Earth's surface. Now, there is probably a number of latitudes that already know. Already we know equator as a latitude. Already we know Tropic of Capricorn as also a latitude. We know Tropic of Cancer as a latitude. And we know Greenwich Meridian or Prime Meridian as what? As a longitude. Do you know any other longitude apart from Greenwich Meridian or Prime Meridian? And where did this name meridian come from? Have you ever asked yourself where this name meridian comes from? Now, the name meridian, before we end this, we will know where the name meridian comes from. So let us continue. Now, the next thing, let us now talk about these circles, these spheres, I mean. Let us talk about these spheres. So I want us to discuss these two spheres. Sphere A, note the circles drawn in sphere A. We have the circle A, the circle B, and the circle C. In sphere B, we have all circles meeting the North Pole and the South Pole of the sphere. Underline the word sphere, of the sphere. So in A, what can we talk about as far as A is concerned? What can we talk about? So in A, we have some things that we need to understand. In the diagram A, number one, we know that the circle A, that circle at the top, divides the sphere into two parts. But one thing we are sure of, are these parts equal? No. The upper part is smaller than the downer part. The spheres, the two parts won't be equal. So circle A divides the sphere into two unequal parts. So that's one thing we need to note. So we can just say roughly, because of time, we can say circle A, so A capital, divides the sphere into two unequal parts. So already we know it will divide the circle into two parts, but these parts will be unequal. So two unequal parts. That's one thing we need to understand. So with the upper part smaller than the downer part. So if you look at the upper part of, if we cut this sphere along the plane of circle A, the small circle on top there, you realize that we are going to divide the sphere into two parts, but the upper part will be smaller than the downer part of the sphere. Good. Similarly, if you now consider B, if we consider now circle B, not point B, please, not example B, we are considering circle B. So if we consider circle B, what do you have? Circle B is dividing the sphere, but since it is passing through the middle of the sphere, if we cut the sphere along circle capital B, we are going to obtain two equal parts. So the upper part and the downer part. Should we cut circle B? Should we cut the sphere along circle B? Understand this. We are going to obtain two equal parts. So these parts will be half, half, 50-50, half, half. Now, ask yourself, so what is the name? What is the name of a half of a sphere? What name do we call a half of a sphere? Can you type it down there? What name do we call a half of a sphere? So when we divide the sphere in A along the plane of circle B, we are going to obtain two equal parts. The upper part will be equal to the downer part. So what can we say here? Circle capital B divides the sphere, not the square, please. This is a sphere. So divides the sphere, So we are supposed to say sphere. So divides the sphere into two equal parts. Now, circle A, we said divide the sphere into two unequal parts. Circle B divides the sphere into two equal parts. What about circle C? What about circle C? Does circle C divide the sphere into two equal parts or two unequal parts? Can you think about that? What about circle C? So if we cut the sphere along circle C, remember the upper part will be bigger than the downer part. The downer part will be small. So meaning that circle C is also dividing the sphere into two unequal parts. Let us say that circle C that is now C capital, divides the sphere into two unequal parts. So among the circles in part A of whatever we are considering, the sphere A, among the circles drawn on the surface of sphere A, only circle B divides the sphere into two equal parts. Circle A and C divides the sphere into two unequal parts. So in the if you don't want to say unequal, we can say unproportional parts. Now, so here, a circle that divides a sphere into two unequal parts, that circle is referred to as a small circle. What have I said? A circle that divides a sphere into two unequal parts, that circle is said to be a small circle. So right now, we know what a small circle is. Already, our main content here, one thing we were looking at, great circles and small circles. That's the first thing Greek astronomers and geographers studied, and they never went on the Earth's surface and draw the spheres, the latitudes and longitudes themselves. They were using small spheres that represent the Earth, meaning that they were assuming that the Earth represent a sphere. That's why we say that the Earth is spherical. So they were assuming that the Earth represent a sphere. So under similarity and enlargement, they say that if we determine the Earth, the North Pole and the South Pole of this small sphere here, that is also the same as determining the North and the South Pole of the Earth. If we can draw circles from east to west in a sphere, meaning that also there are imaginary circles that can be drawn on the sphere of the Earth now or on the Earth. So if they can determine the distance along a small sphere or a circle on a sphere, then also they can determine the distance along the Earth surface. And that's why we are here. So in whatever we are considering, one thing the first part of our lesson, we are looking at a great circle and a small circles. We want to know what is the difference between these great circles and what is the difference between great circles and small circle, or what is a small circle and what is a great circle. What is a small circle and what is a great circle? You need to understand that. So here we need to also learn and say, they also considered whatever we are considering. Already they drew an example, for example, whatever we are considering, a sphere in part A and a sphere in part B. So they drew circles that are perpendicular to the axis of that sphere. And also they drew the circles that are also in the direction of the Earth's sphere, as in B. I hope you can see the diagram, as in B. So under this, we have said that in part A, we have the circle above there divides the sphere into two unequal parts, circle A. Then we have said that circle B divides the sphere into two equal parts, meaning that it passes, if we cut that sphere along circle B, what are we going to obtain? We are going to obtain two hemispheres. The half of a sphere is referred to as two hemispheres. And if we cut the sphere along circle C, the upper part will be bigger than the smaller part, the downer part. So they made a conclusion and said that a circle that divides the sphere into two equal parts is referred to as a great circle. What have I said? What have I said? Imagine they said that a circle that divides a sphere into two equal parts is said to be a great circle. So let us write that. So let us say a circle, let us note that point down. A circle that divides the sphere, into two equal parts, So the circle that divides the sphere into two equal parts is called a great circle. Is called a great circle. So a circle that divides the sphere into two equal parts is called a great circle. So we can write this a circle that divides the sphere into two equal parts is called a great circle. So we can call it great circle. So already we know what a great circle is, and a circle that now divides a sphere into two unequal parts, that circle they named a small circle. So we can also, that's point number one. Point number two, you say a circle that divides the sphere, a circle that divides the sphere into two unequal, so underline the word unequal parts. So unequal is very easy to understand. Equal, unequal. Identical and identical. So we know, this person is not fair. He did not, or she did not divide these things into two equal parts. But we have fair circles that divide the sphere into two equal parts. We call them great circle. or great circles, and we have unfair. So we can use the word unfair. You are used to the word unfair. So we can use the word unfair circles. These are circles that divide the sphere into two unequal parts. So when somebody is unfair, this person, when he's dividing things, you know that things won't be equal. So we can say a circle that divides the sphere into two unequal parts, we can call it a small circle. So a circle that divides the sphere into two unequal parts, So I've written parts into two unequal parts is called is called so what name do we call it? A small circle. A circle that divides a sphere into two unequal parts is referred to as a small circle. So right now you know small circles and great circles. A small circle is a circle that divides the sphere into two unequal parts. A great circle is a circle that divides the sphere into two equal parts. So that is the difference between a great circle dividing the sphere into two equal parts. So we can also call it what? A fair circle. This circle is very fair. Yeah, it's very fair, meaning that it is dividing this sphere into two equal parts. Then a circle that divides the sphere into two unequal parts, we can call it a small circle. So we can say it is called a small circle. So we can call it a small circle. We can call it a small circle. So we have small circles and great circles. Great circles divide the sphere into two equal parts. Small circles divide the sphere into two unequal parts. Small circles divide the sphere into two unequal parts. Great circles divide the sphere into two equal parts. So is there anything that you don't understand as far as small circles and great circles are concerned? Is there something that you don't know as far as small circles and great circles are concerned? Let me know. I have time today, and provided that we have suitable condition, we are going to learn, all of us. So the first part of longitude and latitude is knowing the difference between small circles and great circles, and these are what Greek geographers and astronomers were struggling with. Now, after knowing great circles and small circles, why were they learning small circles and great circles? They took a sphere that is not the Earth and used that one as a similarity. They assume that the Earth is also spherical. So in order to understand the whole Earth, they were using a representative of the Earth. So this representative of the Earth is a small sphere, for example, a ball. A ball is circular. A ball, or let's say a football, is very circle, perfect shape. So they were using the sphere of that ball to compare the Earth. That's why we are using the sphere here to compare the Earth. Now, remember in figure A, only circle B is a great circle. And in figure B, remember, if we cut the sphere along any circle in B, we are going to obtain two hemispheres, meaning that two equal spheres. So what does that one tell us? Suggest. What is the meaning of that? All circles in B are great circles. Aha. All circles in B are great circles. So we can say in a B, when a sphere is cut along any circle, when a sphere in B when a sphere is cut along any circle, we obtain, so we say any circle in B, when a sphere is cut along any circle, two hemispheres are obtained, meaning that two equal parts are obtained. So two equal parts are obtained. So what does that one tell us? In A, we say that only B divides the sphere into two equal parts. But in figure B here, in this our figure B, we are saying that if we cut the sphere along any circle in B, two equal parts are obtained, or two hemispheres are obtained. But in figure A, it is only circle B divides the sphere into two equal parts. So what does that tell you about figure B? All circles drawn in figure B are great circles. Very good. Let us write that. You can say that all circles drawn in part B, drawn in part B are great circles. We call them great circles. So already we know the difference between a great circle and a small circle. And we are saying that all circles drawn in B are great circles. So what does that one tell us? They divide, if we cut the sphere along any circle in B, we are going to obtain two equal parts. So all circles in figure B, in simpler terms, all circles in figure B are fair circles. Very good. Now, already we know great circle and a small circle, and we know the difference. So in B, we say that all circles are great circles. In B, all circles are great circles. In A, we say that only B is a great circle. Other circles divides the sphere into two unequal parts, and they are called small circles. So the first one, we know the difference between a small circle and a great circle. We know now the difference between a small circle and a great circle. So after knowing the difference between a great circle, let us move straight to the latitudes. So let us, these geographers and astronomers, they did this one for us. So we are just tracing the works that they did. It's not my works, but the works of ancient Greek philosophers, Greek astronomers, and also Greek geographers. They did this on our behalf, so we don't need to struggle knowing. So here we have latitudes. So you can write latitudes here. So latitudes. So after comparing the sphere, the two spheres drawn, so they act as a representative of now what we should know about the Earth. So what we should know about the Earth also, let us start with the latitudes. Latitudes. So what are latitudes? Already you know examples of latitudes. So what can we say? What are these latitudes? Imaginary lines drawn across the Earth's surface. That's one way of saying it. Imaginary lines drawn across the Earth's surface. That's a latitude. Another way we can say these are circles drawn on the Earth's surface whose planes are perpendicular to the Earth's axis. What do we say about that? Already we know the Earth is rotating on its own axis, and it takes how many hours? How many hours? 24 hours, right? The Earth is rotating on its own axis and is taking 24 hours to rotate. So as it rotates, we are being told that we have lines drawn, imaginary lines drawn on the Earth's surface. These lines, their planes are perpendicular to the Earth's axis. So these lines, we call them latitudes. Very different from longitudes. Latitudes, their planes are perpendicular to the Earth's axis. So in simpler terms, who want to struggle? We don't want to struggle. Let us say that they are lines drawn across the Earth. Lines, so they are lines drawn across the Earth. Lines drawn across the Earth's surface. Lines drawn across the Earth's surface. So the lines drawn across the Earth's surface, we call them latitude. So as a mathematician, we can say that we know the word perpendicular and we know planes. Plane is a 2D. It is something like a shape, a flat surface. So we can say their planes are perpendicular. Another thing we can say, the planes of latitudes, all of them, there's no latitude exempted from this. The planes of latitudes are perpendicular. Underline the word perpendicular. Are perpendicular. Are perpendicular to what? Are perpendicular to the Earth's surface, to the Earth's axis, I mean. To the Earth's axis. That's one thing we need to understand also. The planes of these latitudes are perpendicular to the Earth's axis. Then, another thing about so if we need to use a diagram here. So let us use a diagram here and exhaust these latitudes. So if we have the Earth, assuming that this is the Earth, so we have the Earth's axis. That's there. So we can say Earth's axis. Earth's axis. So the Earth rotates on its own axis. Then now we have the latitudes. So the first latitude can be here, drawn up there. Then we have another one must be passing through the center, meaning that we have a latitude that divides the Earth into two equal parts. Then we have another latitude down here. We have another latitude down here. So this latitude, we can name it latitude M, latitude N, latitude O. So I want you to look at this latitude. So this now the Earth. We can say this now the Earth. So this is our Earth. And you can see the latitudes drawn. So we have latitude M, latitude N, and latitude O. So I'm saying if we have the center of this, the circle N, and the center of circle M, and the center of circle O. So the center of circle O, you see where it is. And the center of circle N, you are seeing where it is. Very different. So this outer line I'm drawing here, this is now on the Earth's surface, meaning that it is an arc, part of the circle N. Then the line here that is also dotted, the other dotted part is also the arc, which is part of the circle N. Then also the line here, which is undotted, is the part of circle M. So it is an arc. Now, so if I draw the radius, a line from the center to the circumference, that is the radius. A line from the center to the circumference. So you can see whatever I'm talking about. A line from the center to the circumference. So I'm saying the planes of this latitude must be perpendicular. So for example, N, it is perpendicular like that. M perpendicular like that, then O perpendicular like that. So are you seeing the differences? M and O, they are circles. Then they are planes. The plane is also a circular what? A circular top. Let's say a circular region. So it is circular form. So perpendicular to the Earth's axis. So that is whatever we are talking about. Now, next, since among in latitudes, there must be one latitude. The same way in the figure we saw above, in this figure here, in figure A, we have two figures here. In figure A here, we say that circle B divides the sphere into two equal parts. Then also in latitudes, we also have a circle that divides, or a latitude that divides the Earth into two equal parts. So this latitude, it is passing through the center, meaning that it cuts the Earth, or it divides the Earth into two equal parts. So the upper part is referred to as, what's the name do we call the upper part? In when you're talking about the Earth, what name do we call the upper part? Yeah, we call it the northern hemisphere. And the downer part, what name do we call the downer part? Yeah, we call it the southern hemisphere. So without the circles, the spheres we considered in our previous part, we could not understand the latitudes. So here we are saying that among the latitudes, we have the latitude that divides the Earth into two equal parts. That latitude is referred to as, what name do you call it? Equator. Very good. So among the latitude, equator is a great circle. So you say that equator is a great circle. So what can we say? Among the latitudes, among the latitudes, among the latitudes, only equator is a great circle. Good. So among the latitudes, only equator is a great circle. So if equator is a great circle, it means it divides the Earth into two equal parts. And the center of the equator is the center of the Earth. What have I said? The center of the equator is the center of the Earth. So we are saying that among the latitudes, only equator is a great circle. All other latitudes are small circles. Now, all other latitudes, all other latitudes are small circles. Small circles. Then another thing that I need you to understand here. So since equator is the only great circle, equator is used as a reference point. What have I said? Since equator is a great circle, it is the only great circle among the latitude, it is used as a reference point from which all other latitudes are named in degrees north or south of it. And how can we represent equator? What is the angle of equator? 0 degrees. So equator is assigned 0 degrees. Why? Because it is a reference point. For example, if we talk of an integer, we are drawing a number line representing integers. We are going to start the center of all the integers 0. Then we have the negative integers to the left and the positive integers to the right. So meaning that we must have a reference point. Either you are positive or negative. Where is our reference point? 0. So equator is assigned 0 because all reference points are always assigned 0. So equator is used as a reference point, from which all other integers, from which all other latitudes, I'm used to integers, from which other latitudes are named in degrees north, north, n are named in degrees north or south, are named in degrees north or south s of 8. So we are saying that equator is used as a reference point from which other latitudes are named in degrees north or south of 8. So since it is running across the Earth's surface, and equator divides the Earth into 2 equal parts, so we named the upper part northern hemisphere and the lower part the southern hemisphere. So all other latitudes to the south are all other latitudes in the southern hemisphere are named south of the equator. All other latitudes in northern hemisphere are named in degrees north. North of what? I want you to understand this. Degrees north. North of what? Degrees north of the equator. South of the equator. That is one thing I need you to understand. So, among the latitudes, what are the key points? Number one, they are the lines drawn across the Earth's surface, and they are planes, or they are circles drawn across the Earth's surface. And they are complete circles, meaning that if you start drawing them at a point, you will go around the Earth and come at the same point that you started. So, they are complete circles. Let us note that down to avoid forgetting. Latitudes are complete circles. They are complete circles. So latitudes are complete circles. That is one thing we need to understand. Now, another thing that we said, their planes are perpendicular to the Earth axis. So if you say the Earth axis is straight, their planes must be perpendicular, meaning that if the Earth axis is vertical, the planes will be horizontal. Are we together? Next, all latitudes are small circles except one. Which one? That is equator. Why are we saying equator? Equator is the only latitude that divides the Earth into 2 equal parts. And these parts, what are their name? The northern part is referred to as northern hemisphere. The southern part is referred to as the southern hemisphere. That's one thing we need to understand. We have the northern hemisphere and the southern hemisphere. Now, since it is only a great circle, what are we saying? Since equator is the only great circle, it is used as a reference point, meaning that we cannot name a latitude. We cannot name a latitude without referring it to equator. So it is used as a reference point from which all other latitudes are named in degrees north. North of what? North of the equator, and degrees south. South of what? South of the equator. That's the one thing we need to know. So equator is a reference point. And any reference point is assigned 0. So equator is also assigned 0. Let us label that here. Equator is assigned 0 degrees. So we can say equator and 0 degrees. So 0 degrees. So if you're asked, why is equator assigned 0 degrees? It is a reference point from which all other latitudes are named in degrees north or south of it. So all other latitudes in this northern hemisphere are named degrees south of the equator. All the latitudes in the southern hemisphere are named in degrees south of the equator. Equator is the reference point. Then another point we need to understand, these latitudes are parallel to each other. They are parallel to each other. So meaning that Tropic of Capricorn is parallel to equator, and equator is parallel to the Tropic of Cancer and all other latitudes. So ask yourself, between Tropic of Capricorn and Tropic of Cancer, which one is in the northern hemisphere and which one is in the southern hemisphere? Let me know in the comment section. And if you're getting me clearly, please, I don't want to be talking to myself. Let me also know if you're getting me clearly. So moving to the next thing, and before we move to the next thing, I want us to note one thing here among the latitudes. So among the latitudes, we can say that small circles are referred to as parallel of latitudes or parallel of latitude. Small circles, we can say that small circles are called parallel of latitude. So we call them parallel of latitudes. So small circles are also called parallel of latitudes. So we have exhausted, we know what latitudes are. We know that the equator is the only great circle among the latitudes. And we know that all other latitudes are named degrees north or south of the equator. And equator, since it is a reference point, it is assigned 0 degrees. It is a reference point. Then another thing, the maximum angle of a latitude. That's one thing that I don't want us to forget. There's no a latitude that's greater than 90 degrees. That is one thing that you need to understand. So say that the maximum angle of a latitude is 90 degrees. North, the maximum angle, of a latitude, the maximum angle of a latitude is 90 degrees. So 90 degrees what? North or south. So meaning that from 0 degrees equator, we move to the southern hemisphere, the maximum angle is 90. From the equator, we move in the northern hemisphere, the maximum angle there is 90. So the maximum angle of a latitude is 90 degrees north or south of equator. So equator is our reference point. So the maximum angle of a latitude is 90 degrees north or south of the equator. So among the latitudes, we say that only equator is a great circle used as a reference point. Latitudes are complete circles, meaning that they go around the Earth, then come back. Then small circles are also called parallel of latitude. Then the maximum angle of a latitude is 90 degrees. So with that, if there's something that I've forgotten, please let me know. If there's something I've forgotten, please let me know. But for now, let us see how to determine the angle of a latitude. So the next subtopic, let us write angle of a latitude. So we want to see how we can get the angle of a latitude. How can we get the angle of a latitude? If we say that, oh, it is 70 degrees north or 67.5 degrees north, what are we talking about? North of the equator. How are geographers and astronomers determining the angle of each and every latitude? Already we know the angle of equator. And how have we known that? Equator is a reference point and all other latitudes are named in degrees north or south of it. So if it is a reference point, all reference points are assigned zeros, meaning that geographers and astronomers, they assigned equator 0 degrees. They assigned equator 0 degrees. So we want to see how we can get the angle of a latitude. We want to see how we can get an angle of a latitude. That is our next point. So if you are new here, this is Teacher John teaching, and here is Kenya Science Academy online. We run structured programs also. We transform all those committed struggling learners to academic giants in only 12 weeks. And we have a structure for doing that. So subscribe to this YouTube channel. This is where we will be talking about points generally, teachers, learners, those people that were in school. If there's something that is not clear, you just let me know. And also, if there's something, a point that I'm forgetting, please let us remind ourselves. It is a reminding session. And we are looking at the works of great Greeks, astronomers and geographers who took their time to study these latitudes and longitudes and name them for us, as we are just using them as pilots. So I said that at the start of this lesson, assume you're a pilot, we are learning this to ensure our plane lands smoothly. So let us consider a diagram. So as angle of latitude, how are we going to determine the angle of latitude? So take example, this is now the Earth's surface. This is the Earth. Then we have a latitude in the northern hemisphere. So we say latitudes are complete circles, a latitude in the northern hemisphere. Then we have equator. So equator is the only great circle. So we will be referring to equator all the time since it is the only great circle that we have. The equator. Then we have another latitude in the southern hemisphere. So this is the center of the equator, and we say that center of the equator is the center of the Earth, and this now the center of the latitude in the northern hemisphere, and now this is the center of the latitude in the southern hemisphere. So if we have a point here, P, so the latitude in the southern hemisphere, in the northern hemisphere is passing through point P there. I hope we are together. Then we have equator, let's say name it O, and we know that the angle is 0 degrees. So the angle of equator is 0 degrees. So a reference point is not the same way we can say 0, we cannot say -0 and +0. We cannot say that. All the reference points are given their 0. No negative, no positive, no degrees north or south. So it is 0 degrees. It is not north, it is not south. Then the next point here, we have point Q. So let us name that point Q. We have point Q. So point P, point O, and point Q. So to avoid confusing this O and 0, let us give it another name. So we can say PQR. So I can name this one. Sorry, I can name this one M, and this one I'm going to use a name that we can remember. PQ, alphabetical order. PQR. Yeah, okay. So PQR. Good. So I have PQR here. So we have PQR. So the name, this latitude P, we don't know its name, but we are aware of latitude Q. It is equator. Let me emphasize that this is equator. Equator is the only great circle there. Then we have R here. R, we don't know R. So R is in the southern hemisphere, is a latitude passing through R in the southern hemisphere, and we have a latitude passing through point P in the northern hemisphere. And we have a latitude Q, which is now, in this case, is our equator, the only great circle among the latitude. So from this point, let us draw the radius of the Earth in this case. It is passing through, it is from P to the center. That's the radius of the Earth. Then we have to the point Q. Then we have another radius passing like that. So we have PQ is an arc. QR is also an arc. Point P lies on the northern hemisphere. Point Q is a point on equator. Then point R is a point on a latitude that is on the southern hemisphere. Sorry. Now, here we have PQ, this arc, we have this arc here, PQ, and we have arc QR. So let's say that arc PQ, well, since here is 0, and we say that the maximum angle here is 90 degrees. Excuse me. Thank you. So point P is a point on the latitude that is now in the northern hemisphere. Point R is a point on the latitude in the southern hemisphere, and point Q is on the equator. So what I want to emphasize, and listen carefully, PQ, if I start from QP, the maximum angle here is 90 degrees north of the equator, and the max, so this is now, if we say that here we have the North Pole, and here is the South Pole of the Earth, and the Earth's axis is passing through the centers of these circles. So we say that QP is an arc, and QR is also an arc. So let us start with the arc QP. So from 0, the angles are increasing in that direction to 90. Also, these ones are increasing in this direction from 0 to 90 maximum. So this now 90 degrees north, south, I mean, 90 degrees south, 90 degrees south. So this one is the south. So QP subtend an angle. Let's say that the angle subtended by QP here, let us give it theta. QP subtend an angle of theta degrees. Then QR, the arc of QR, subtend an angle here, alpha degrees. So I want us to consider those. So arc PQ subtend theta at the center of the circle, or the center of the arc. So this sphere here, we are talking about the earth. QP subtend an angle theta at the center of the earth, and QR subtend an angle alpha at the center of the earth. So how are these geographers working? So These geographers said if QP is the angle subtended at the center of the Earth from the equator's arc, or from the arc of the equator, if QP subtend an angle theta from the arc of the equator, then this theta is also the angle of the latitude passing through point P. What have I said? If QP subtend an angle theta at the center. So this is now the angle we are talking about. This is now the angle theta, and this is now the arc QP. And it subtended this angle at the center of the Earth. So these geographers and astronomers, they came to realize and they came into conclusion and said, this QP, since QP is from the arc of the equator towards the north, and QP subtend an angle at the center here, theta, then this angle theta is the angle of the latitude passing through this point P here. So this latitude here, it is theta degrees. It is, so this P here is theta degrees. So P, the latitude passing through point P is theta degrees, but it is in which part of the hemisphere? Is it in the northern part of the hemisphere or the southern part of the hemisphere? So since it is in the northern part, it is referred to, we are going to say it is theta degrees north. North of what? North of the equator. So this arc PQ subtend an angle theta degrees at the center of the Earth. So theta degrees will be the angle of the latitude passing through point P in the northern hemisphere. So the latitude P is theta degrees north of the equator. So can you tell me the angle of the latitude passing through point R? Very simple now. So you say that QR is the angle, and please, I'm using equator as my reference point. Name, from the beginning of the latitudes, we said that equator is used as a reference point from which all other latitudes are named in degrees south, north, or south of 8. So we are using our reference from the equator. These angles are named from the equator. And we say that angles are increasing to the maximum 90 in the North Pole and to the maximum 90 in the South Pole. So QR subtend an angle alpha at the center of the Earth. So the arc QR from the equator, from the arc of the equator, or from the surface of the equator, it subtend an angle alpha at the center of the Earth. So since Q is on the equator, we say that the angle of this latitude passing through point R in the southern hemisphere, the angle is alpha degrees, but since it is in the south, we say alpha degrees south. South of what? South of the equator. North. North of what? North of the equator. So that's how they were using two things. Geographers and astronomers were using two things to name the latitudes and to give them their angles. What were they using? One, they were using the center of the Earth, which is also the center of all the great circles on the Earth's surface. Then they were using equator, and you say equator. Why are they using equator? They are using equator as a reference point from which all other latitudes are named in degrees north or south of 8. Then we're using the arcs on the Earth's surface, the arcs of great circles on the Earth's surface. So this is the arc PQ, meaning that it's from the reference point Q to a point P, meaning that this point P is also on the surface of the Earth. Then here, QR, they were using the equator Q and R here. And this R is also a point on the Earth, but in the southern hemisphere. So this QR subtended subtend theta. So even if we say an angle of 67.5, meaning that that angle is the angle an arc is subtending at the center of the circle, or of the center of the earth, I mean. So that is what I wanted you to understand as far as angle over latitude is concerned. So here, let us just write short notes here so that we don't forget, and also wherever you are, ensure you are writing them. First, so let us note and say PQ subtend theta. So PQ subtends an angle theta degrees at the center of the earth. That's one thing we need to understand, at the center of the earth. Then theta, so since Q is on equator, and I'm emphasizing equator as a reference point here. Since Q is on equator, the angle of the latitude, passing through point, point P is, so is what? Is theta degrees north. That's the first part of our note. The second part, we can say QR subtends alpha degrees at the center. So here I forgot to say at the center, so add that center here. At the center of the earth. So at the center of the earth. So QR subtend an angle here alpha degrees at the center of the earth. So what can we say about that? We can say the angle of the latitude passing through point, point R. Where is point R? In the southern hemisphere. So through point R in the southern hemisphere is alpha degrees south. South of what? South of the equator. North. North of what? North of the equator. So all the angles that you are going to name the latitudes are the angles that the arc from that point where the latitude is passing subtend at the center of the earth. That is one thing that I wanted you to understand. So if you still don't know, or if you still don't understand, or if there's something I've forgotten, please in the comment section, and my fellow colleagues, teachers, let me know if there's something I've forgotten and you are following, please. I don't want to mislead here. I cannot be seeing everything, but you can tell me in the comment section. If you are getting me clear, let me know. So this is how we get the angle of a latitude. Very clear. Next thing, latitudinal difference. And we are still going to use the same diagram to get our latitudinal difference here now. So latitudinal difference. Latitudinal difference. So latitudinal difference, or the difference in latitudes. So stroke difference in latitudes. How can we get latitudinal difference? How can we get the latitudinal difference? These were all calculated for us, so we don't need to struggle. How can we get latitudinal difference? How can we get latitudinal difference? So difference in latitude. So let us consider the latitudes P and latitude R. We want to get their difference. And also latitude Q, which is equator. So what is latitudinal difference? So the difference in the angles of the latitude, the difference in the angles of these latitudes are referred to as latitudinal difference. The difference in angles of these latitudes that we have here. So the difference in angles of these latitudes are referred to as latitudinal difference. So if we know the difference of the angles in latitude, one thing we need to understand, there's some latitudes on the same part of the hemisphere, or in the northern hemisphere, all latitudes in the northern hemisphere and all latitudes in the southern hemisphere. Then we have a latitude in the northern hemisphere and a latitude in the southern hemisphere. How can we get their differences? So I wanted to use this example, but I'm going to make my diagram dirty, so I'm going to draw another one. So we say consider, we are looking at latitudinal difference. Let us consider another diagram. So here, let's consider the Earth's surface with the equator, and another latitude up there, and another latitude down here. Now, so this is the center of the Earth. Now, I'm going to draw here. We have this P, then we have Q, then we have R. So I'm going to draw the radius. This is the radius. This is another radius, and this is another radius. So we have already PQ, we know that it subtend an angle theta here, and QR subtend an angle, we can say alpha here. So how can I get the latitudinal difference here? The difference in this latitude, we say that this latitude is what? This latitude is theta degrees north of the equator, and this latitude is alpha degrees south of the equator. So equator, we know, is already 0 degrees. No north, no south. So from equator to 0, from equator to P, from Q to P, already we have latitudinal difference between equator and P. So from here we can say the latitudinal difference, or the difference in latitude between the equator Q and the latitude P is gotten by taking the difference. So we subtract. It's gotten by subtracting P minus 0. So when we are getting the latitude, remember that we are also, the difference in the latitude, we always subtract the bigger angle minus, we take the bigger angle minus the smaller angle. So it will be P minus Q. So the angle of P minus the angle of Q. That is one thing I want you to understand. Next, very fast, latitudinal difference, latitudinal difference, latitudinal difference between R or Q and R. So already we know Q and R is still, Q is 0 since it is the equator. I don't want you to forget that. Q is 0 since it is the equator. What am I going to say? I'm going to say it will be R minus Q. So latitudinal difference there will be R minus Q, R minus Q. So it is 0 degrees Q, P is on the north and R is on the south. P is Q theta degrees north and R is alpha degrees south. So P minus Q, if I say P minus Q, so it will be theta degrees minus 0. I get the longitudinal difference. Latitudinal difference, I mean. Latitudinal difference between R and Q, which is now R is a latitude on the southern hemisphere and Q is equator. It is R minus Q. And R is alpha degrees south, Q is 0. So it will be alpha minus 0. Now, what is now the latitudinal difference between P and R? They are on the different side. P is on the north and Q is on the south. How can I get latitudinal difference? You can say latitudinal difference between P and R. So what is the latitudinal difference between P and R? Since they are on the same, so latitudinal difference, it is difference in angles between this point P here and this point Q. So if you take from R to 0, from R to 0 is alpha degrees. Then from Q to P is also theta degrees, meaning that if the latitudes are on different side of the equator, if the latitudes are on a different side of the equator, then their latitudinal difference is gotten by adding. So latitudinal difference will be angle of P plus angle of R, which is now, it will be theta degrees plus alpha degrees. So I get the latitudinal difference. That's why we say that when they're on the same side, subtract. When they are on different side, add. Now, let us continue. What if P and Q are on the same side? Like now, P and Q are on the same side. What are we going to say if P and Q are on the same side? How are we going to represent this? So if we have a diagram here and another diagram here. So here we have equator, then we have the latitude here, another latitude here. So then this now equator. Then in this side we have equator, then here we have a latitude here and a latitude here. So here all these latitudes are on the northern hemisphere. All these latitudes are in the northern hemisphere. So P and Q. Here they're on the southern hemisphere. P, Q. And here we have the equator. We have the equator here. So if you have the equator here, the difference in the latitude, so latitudinal difference, the difference in latitude here. So already you know how to get the latitude of P and latitude of Q, the angle of P and the angle of Q, and also the angle of P here and the angle of Q here. We know how to get all that. This side, they are on the northern hemisphere, but all of them are from the equator. So this one are in the southern hemisphere, all of them, they are also from the equator. So here is in the same. So if you look by just looking at the diagram here, the diagram, I can name this one A and this one B. What is the angle of between angle P, angle of latitude P and angle of latitude Q? Which one is bigger than the other? You realize that the angle of latitude P is greater because it is increasing from 0 to the maximum. This one also increasing from 0 to the maximum on the southern hemisphere. This one in the northern hemisphere. What is the difference? Now, the longitudinal difference here, so we can say in A, latitudinal difference is given by taking the angle of P. So I'll just write it. Angle of P minus angle of Q. Why? The angle of P is proven to be bigger than the angle of Q. Then in B, so what is the latitudinal difference here? Latitudinal difference here is gotten by taking angle, so is equals to angle of Q. So in this diagram, it is arranged so that we can think. In A, look at here, P. P has a greater angle minus compared to Q. Then here, I have accidentally arranged them, but it can also help us think. Between angle P and angle Q, we say that it is increasing, the angles are increasing from the equator. So if this is the equator, the angles are increasing downwards, and in A, if this is the equator, the angles are increasing upwards. To where? To the North Pole. Here is increasing downwards. To where? The South Pole. So the latitude of P is from 0, small. So from 0, we move to P, then Q. So Q has a greater angle compared to P. So it will be the angle of Q minus angle of P. That is how we get the latitudinal difference between P in A and P and Q in A and P and Q in B. So that is how we get the latitudinal differences. I mean, everything I've now talked about the latitudes. So where did we start? We started from the latitudes. So already we know latitudes. Everything concerning latitude is written here. The angle of the latitude, already we have talked about how the geographers and astronomers in the past were calculating and were representing and were naming the angles of each and every latitude that now we can think of on the Earth's surface. Latitudinal difference, we have talked about the latitudinal difference between a latitude and equator, and latitudinal difference between two latitudes apart from the equator. And we have said if they are in the same side, in the same hemisphere, we subtract them. So subtraction, we take the bigger angle minus the smaller angle to get the latitudinal difference in the same side. In different side, we say we add. Why are we adding? Because it is now the difference between a point here, P to Q. That's why we are adding. So it is this angle plus this angle is giving us the differences in angles between P and Q. So with that, we are done with everything concerning the latitudes. Everything concerning the latitudes. So if you have just joined, please consider subscribing to Kenya Science Academy. We'll be dealing with CBC and 844 system. Then from here, we'll be dealing, we are going to have another channel that we will be dealing with international systems like IGCSE, Cambridge, and Excel, and IB, International Baccalaureate. IB, International Baccalaureate. We'll be dealing with that system also here. So if the system that you are learning that does not have these longitudes and latitudes because it is not there in or level of IGCSE, please let me know. I am Teacher John, and I am your storyteller. I'm telling the stories of the ancient Greeks who are astronomers and geographers, and they decided to draw this latitude and they already imagine them because we say that they are imaginary. They are imaginary lines, so we don't know that they exist. They are imaginary. That's one thing we need to understand. Already, we know anything concerning the latitude. So subscribe, please. Why are you subscribing in the first place? To promote. So like the live, please. I don't know what is going on. If you can hear me, please let me know. If I'm not clear, also let me know. I want this message to reach all the candidates of this year, Form 4s that are struggling in latitudes and longitudes, and Form 3s of this year, which is now next year's for candidates. These lessons I'm doing for your sake. Then the next thing, I am Teacher John, as I've said, and we are running in Kenya Science. We are learning and running programs one-on-one through Google Meet. And if your child, daughter, or if you are now the candidate and you're struggling, if you want to know maths, you want to know sciences, chemistry, physics, biology, consider contacting the number. And the number is, let me write it here. The number is 07 90199736. This is our channel number and also our consultation number. So consider reaching us via WhatsApp because calls, we can be in classes, so we don't have time for picking, but we are going to get back to you if we receive your message on our WhatsApp. So with that, subscribe if you are new. If this live has reached you, I don't know how many people are watching this, but I knew even if it is one person watching or nobody, they will find me on the way and they will watch. So share the live, subscribe to the channel, like the live. Let us make math fun learning. So it's a storytelling, guys, and this is whatever we do in Kenya Science. Let us move to, we are done. Imagine everything that we are talking about was concerning the latitudes. So I hope you are eager to know about the longitudes. So let us move to the longitudes. Let us move to the longitudes. So we have talked about the latitudes, so we have the longitudes now. Longitudes. So longitudes. So as we are talking about the longitudes, I want you to also remember that we started from knowing great circles and small circles. And this is where we started, great circles and small circles. So part B, we saw that we have the North Pole and the South Pole. So this is a sphere that represents the Earth that the Greek astronomers, so we have here Greek astronomers and geographers were talking about. So this is whatever they did. They used a circle, a sphere here to represent the Earth. Now in longitudes, What can we say about longitudes? So we are going to talk about longitudes now. We can say the first thing, they are imaginary lines. So are imaginary. I'm saying imaginary. Why am I saying imaginary? Because there's nobody who actually moved from the north pole of the earth to the south pole of the earth to draw this line. And if they are drawn, uh, if they are just imagined to pass through places, they are imaginary lines. So I don't want you to believe that there is somebody who just moved from the north pole to the south pole and drew these lines. So they are imaginary lines running from the north pole to the south pole of the earth. They are imaginary lines. So we are just assuming that these lines are running, they are there. We are assuming that they are there. That's the meaning of imaginary. So imaginary are imaginary lines running from the north pole, imaginary lines running from the north pole in bracket n to the south pole. South pole of the earth. So are imaginary lines running from the north pole n to the south pole s. South pole s of the earth. So we believe that they are running. So how do they appear if they are running from the north to the south of the earth? How do they appear? So that one will bring us to the diagram. So if this is the earth, this my earth should be okay. So we have, if this is the earth, good. And up here, we have the North Pole. North Pole. Then down here we have the South Pole. So the North Pole and the South Pole. Now, if you have the North Pole and the South Pole, then how are these lines running? So they are running from the North Pole to the South Pole. And the other side, we have another one. So one thing we need to understand here, these longitudes are half circles. They are not complete circles like latitudes. They are half circles. So we have another one running from the north to the south. We have another one. So these are how the latitudes are running from the North Pole to the South Pole of the Earth. So these are longitudes. Now, all longitudes are great circles. We are referring to which point? We are referring to the diagram we drew here when we are dealing with great circles and small circles. Remember, in B, what did we say? If we cut the sphere along any circle, we are going to obtain two hemisphere or two equal parts. That is whatever we need to understand. So also when you're dealing with the longitudes, I want you to understand this. Longitudes are half circles, that is number one. So let us write that point down. Longitudes are half circles. Longitudes are half circles. So they are not complete circles like longitudes are not complete circles like the latitudes. They are half, meaning that if one longitude ran from south to north, then we have another longitude opposite to it running from south to north again on the other side. So, like now, what I can say, if I am the first longitude, then opposite me, I have a laptop. Then the laptop I have in front of me is another longitude I'm facing. So these longitudes face each other and they are half circles. That's one thing you need to understand. Then all longitudes, they are also called meridians. So that's another thing that we need to understand here. Longitudes are also called longitudes are also called meridians. So we can call them meridians. Is a longitude or meridian. They are also called meridians. Meridians. Longitudes are also called meridians. So we can call them longitudes or meridian. Then another point that we need to understand here, longitudes are half circles, we have talked about that. Longitudes are also called meridians, we have talked about that. Next thing, since longitudes, remember, latitudes, we say that equator is a latitude and is the only great circle from which all other latitudes are named in degrees north or south of it. But now come to longitude. If they are all great circles, which one are we going to use as what? As our reference point? I also asked myself, what do you think? Which longitude are we using as our reference point? Now, the geographers, we are talking about, we are telling the stories of geographers and astronomers in the ancient Greek, in ancient Greece. That's one thing you need to understand. So we have these geographers. They were also perplexed and amazed. They were also surprised. If all these longitudes are great circles, then which one are we going to choose? So they chose one. This longitude chosen is referred to, passes through London, Greenwich, London, and the same longitude passing through Accra, Ghana. So that longitude passing through Greenwich and Accra, that longitude was named Greenwich Meridian. Why is the name meridian? Longitudes are also called meridians. So that longitude is referred to as Greenwich Meridian. And since it is Greenwich Meridian, it is used as a reference point. So Greenwich Meridian, a longitude, let's say Greenwich Meridian. So talk of a longitude. So let's say something different. Let's say the longitude passing through Greenwich. Through Greenwich, passing through Greenwich in London. In London is called Greenwich Meridian. So Greenwich, we know that Greenwich is a place. It's not something that is magical. Like we say, we can say Nairobi, Kenya, or we can say Accra, Ghana, or we can say Lagos, Nigeria. So it's just a place where people stay. So the longitude passing through Greenwich in London. Why London? That's also I need to ask myself. The longitude passing through Greenwich in London is called, we can call it Greenwich Meridian. From the word meridian is a name of a longitude, another name I've indicated here. Longitudes are also called meridian. So the longitude passing through Greenwich in London is called Greenwich Meridian. So I said that all longitudes are great circles. So if all longitudes are great circles, meaning that we are going to choose one to act as a reference point. And the geographers back then, they chose Greenwich meridian to act as our reference point. So the longitude passing through Greenwich in London is called Greenwich meridian. And so we can continue and say here, and it is used as a reference point, as a reference. It is used as a reference point from which other longitudes. So it is used as a reference point, from which other longitudes are named in degrees. It is used as a reference point from which other longitudes are named in degrees. So assuming that, let us come back to this diagram. Assuming that this now Greenwich meridian, assuming that it is now Greenwich meridian, and we say that all reference points are assigned what? 0. All reference points are assigned 0. 0 degrees. All reference points are assigned 0. So we assign the reference point 0. We are using prime meridian as a reference point. So here we have the right of Greenwich meridian in that direction. Then we have the left of Greenwich meridian in the other direction. So this right, we call it east. So we can say east of Greenwich meridian. And this side, we call it west. Why? Because if we have north and south, this side is east and this side is west. So meaning that this side to the right of Greenwich meridian, we call the direction is given east. The direction is given east. East of what? East of prime meridian. And to the left side, the direction is given west. So from Africa here, we can say East Africa. So I'm located in Nairobi, East Africa. Then we have West Africa, countries like Nigeria and Ghana, they're in West Africa. South Africa, we have like South Africa as a country. Then Northern Africa, we have countries like Egypt, Morocco, they're in the northern part. So also in the Earth surface here, in the North Pole, South Pole, we have East and West. So if this is now the Greenwich meridian and we are using it as a reference point, it therefore means that we are going to name other longitudes. Like now this longitude here is on the east, and this one is on the east, this one is on the east, and even this red is also a longitude on the east, and this now a longitude on the west, this one on the west. So if we say the longitude passing through Greenwich in London is called Greenwich meridian, and it is used as a reference point from which other longitudes are named in degrees. So it is degrees what? It is degrees named in degrees east. Degrees east, the name in degrees east, E, or west, W. So they are named in degrees east. Can underline this one in red. They are named in degrees east, E, or west. West of what? West of our reference point or reference longitude, which is Greenwich meridian. So this now Greenwich meridian. So we also know that since it is used as a reference point, we can also call it prime. Why is it prime? Because it's the one that is always known. We can also call it prime meridian. So Greenwich meridian is also called prime meridian. Why? Because it is the meridian that is known. The rest are not known. Or do you know other longitude apart from prime meridian? Of course not. So we only know Greenwich meridian. Now, we have talked about longitude being used as half circles. Longitudes are also called meridians. The longitude passing through Greenwich town in London is referred to as Greenwich meridian or prime meridian and is used as a reference point from which other longitudes are named in degrees east or west. West of what? West of it. West of prime meridian. Now, next thing, what else can we say? All longitudes are great circles. Did we say that? All longitudes are great circles. All longitudes, all longitudes are great circles. All longitudes are great circles. So all longitudes are great circles. So that is one thing we need to understand. Now, anything concerning the longitude that I might have forgotten, we have said half circles, meaning that they're not complete. The maximum, good. The next, the maximum angle of a longitude. We can say that. The maximum the maximum angle of a longitude. The maximum angle of a longitude is 180 degrees east or west. East or west of prime meridian. So that's the maximum of angle. So meaning that if we move towards the east, the maximum angle this side to the east should be 180 degrees east. So this is the last meridian or the last longitude. Then the maximum angle to the west also should be 180 degrees west. So the maximum angle of a longitude is 180 degrees east of the prime meridian or 180 degrees west of the prime meridian. So that's one thing that also we need to understand. So we have talked about the teachers and learners, if there is something or anybody, the pilots, we are pilots today, if there's anything that I've forgotten as far as longitudes are concerned, please let me know in the comment section. Subscribe, like our live, share it to your friends and also anybody who needs this. And to those people, if you come across this and you are out of school, you can also share it to others in school and to somebody. It can be your cousin, your child, your daughter, son, nephew, cousins, anybody. Now, angle of a longitude. So already we know everything as far as longitudes are concerned. So angle of a longitude, already we know the angle of one longitude, the angle of Greenwich meridian. So other longitudes, we don't know their angles. So want to know how can we tell, or how did these geographers in the ancient Greece, I mean, how did they come up with the angles? So the angle of a longitude. So that one will take us to the next subtopic, angle of a longitude. So angle of a longitude. angle over longitude. So we want to know how these angles are given. So the same way we dealt with the angles of a latitude, the same way we are going to deal with angles of a longitude. So as usual, let us consider a diagram. So that diagram, I will be drawing the Earth the way it is. This now, assuming that this is the Earth, this is now the North Pole, and this is now the South Pole. And we have the Earth's axis passing from the north to the south. That's now the Earth's axis. Then we are using the two reference points to determine the angle over longitude. Two reference points. We are using prime meridian as the only reference longitude that we have. So we have prime meridian. Draw it like that. Name it prime meridian. Then to the east of prime meridian, I can have another longitude. To the east of prime meridian, we have another longitude. So please, I'm being told that my time is up. Sorry for the inconveniences caused. Teacher John, please subscribe here. Refer very many people. Like our live. We will be live each and every day from 5 or 4. We will be noting you guys. So ensure that you like our live. You comment on whatever you don't understand. Since my time is up and we were to do everything concerning the latitudes and longitudes, I'm begging to stop here. But I'll continue tomorrow from angle over longitude. I'm being reminded it is already 7 p.m. and the time is up, but no problem. Tomorrow I'm coming back and I'm going to start from wherever I have stopped, angle over longitude. So if you've been following, this is the first part. I want us to understand angles. We want to understand this topic, latitudes and longitudes, so that next time, if we come across a problem dealing with angles, we are going to, or dealing with the latitudes and longitudes, we are going to tackle them appropriately. Now, I have to take this opportunity to thank everybody who made it to this live, and those people who contributed, those people that watched maybe and left. And Teacher John, see you tomorrow, same time. Thank you.